There is a powerful temptation sitting on every modern engineer's desk. It is now possible to ask a machine to do the heavy intellectual lifting for you, assembling a complex solution in a matter of seconds. The engineering landscape has fundamentally shifted. This generation of problem solvers has access to shortcuts that can bypass weeks of manual calculation, optimization, and drafting. But this creates a paradox. As the capability of our software rapidly expands, the foundational understanding of the humans using those tools risks weakening. This text from the Qmuzik Prize series highlights the standard for the most successful engineers of the future. The winners of this prize represent an elite group who have navigated this disruption, and they all offer the same warning. For these prize winners, the central mission became protecting their own intellectual depth in an era of automated shortcuts. Denzel Kennan sees this tension play out in the private markets. He's watched smaller enterprises use technology to punch far above their weight, competing with giants that once held a monopoly on scale. However, he cautions that these tools can be deceptive. There is a massive draw for young engineers to wield this power without actually understanding the underlying mechanics of the problems they are solving. To counter this, Kennan relies on a first principles mindset. This requires breaking a complex problem down into its most basic truths, creating a necessary defense against the dilution of critical thought. Engineering thrives in ambiguity. In the real world, you are often required to build the plane while it is already in the air, designing and refining systems while they are in motion. A digital tool that removes the friction of problem solving ultimately weakens the engineer. Without that struggle, they lack the capability to innovate when the software eventually fails. Heinz Stegman encountered this friction while managing high-pressure live operational environments. He oversaw massive civil works and system upgrades inside an active distribution center where the first pallet had to be racked exactly on time. Stegman argues that while AI can accelerate the learning process, it cannot replace the struggle. That struggle, the repetition, the failure, and the resistance is precisely what builds deep professional instincts and reliable engineering judgment. His rule for the modern era is to use artificial intelligence to actively challenge human thinking rather than using it to substitute for it. Removing the struggle from the engineering process results in fragile systems that lack the essential element of human intuition. Ashwin Kamaldian views AI strictly as a multiplier. In his philosophy, the technology is designed to augment human expertise, acting as an extension of the engineer's own skill. This relationship functions like a lever. First principles engineering serves as the solid fulcrum, while AI acts as the lever amplifying impact. If that foundational fulcrum crumbles, the lever becomes useless. The technology has nothing to push against, leading to total system failure. Pierre Leitgren used this amplified problem-solving ability to transition across global industries, moving from mining and strategy consulting to scaling tech operations for Uber and inclusive banking. An engineer's planetary competitive advantage remains the strength of the fundamentals they apply to the technology. If AI is successfully optimizing the math and the code, we have to ask, what is left for the human engineer to optimize? Hilda Kruger, a director of global logistics, found the answer in the humanity behind the supply chain. She focuses on optimizing human relationships and ecosystems. She believes technology should amplify human connections and collaboration. Without this focus, automation simply creates isolated silos that are prone to breaking. Kruger identifies human trust as the most critical factor in the success of any global network. In a hyper-automated world, authentic reliability and clear communication have become the rarest and most valuable engineering assets. The collective insights of these prize winners point towards a Swiss Army knife skill set, a blend of deep technical breadth and the ability to manage complex human systems. The next generation of engineers must embrace ambiguity and build solutions while in motion, handling the unpredictable human elements that an algorithm cannot process. These leaders argue that an engineer's worth is found in the integrity, service, and truth they bring, rather than in corporate titles or optimization metrics. AI provides the engine for the future of engineering, but human struggle, first principles, and trust remain the steering wheel. This closing statement from the alumni series celebrates the innovation and impact of these future-focused engineers, whose work continues to improve systems for millions.